Alright, everyone. This is kind of a weird time for a stream. It's a bit late. Also, web camera, right there. The battery might die because that's a Sony DSLR, so I don't know how long that's going to last. I just wanted to do a quick stream and maybe show a little bit of the progress I've made since the last stream, which was, I'm pretty sure, the end of July of last year. So I've been working on the ASA programming language and compiler a little bit, not a significant amount for almost a year, but I think last time only a few things were executable. It was basically just very simple C-like programs. But since then I've gotten some more complex things working, notably the Pong demo and a few others. So I'm going to show those off and what their code looks like. So let's get this one running. This is the Pong demo. I'm going to show you what it actually looks like first. So basically, to compile, you just do the ASA executable and then pass in the file name, which is just main. Yeah, this is just a single file game. It's pretty simple. Wait, hold on. Oh, it's one directory up. Okay, that took a while to compile. I think it's because I'm running so many things at the same time, but normally it takes like a few milliseconds to compile such a short program. So it wrote the executable to a build directory inside the current directory, just so it's all neat and contained. So I'll just show you what's in there. I don't remember if this is how I had it before, but I also output the assembly and the intermediate representation that LVM uses. And there's also this optimized build, which that's temporary. I don't think I'm going to keep that. But it's useful for debugging. So all of those things are still there. And then you can just run it like any executable. Oh, hold on. Oh, that's on my second monitor. All right, here we go. This is Pong. Wow, even with OBS going, it's still pretty fast. I didn't expect that. I thought it would have slowed down significantly. But yeah, it's just Pong. It's using Raylib just because it's a very simple graphics library, so I figured why not. Let me show you what the actual program looks like. So at the top here we have a use directive, which uses rendering.raylib, which is how you include modules, which is just sort of like containers for code. I'm going to sort of solidify more what that actually means, but I'm going to show you what this module looks like too. Let me do that now, actually, just so you know what that's actually including. So all the modules that are built in to ASA are in a modules folder, which are right next to the compiler itself, so it can like easily find them, and you can also add your own inside of the project directories. So modules, rendering, Raylib. This is basically just a one-for-one copy of the like the Raylib header file that you can include in C++. And let's see. So basically you define a module with the Raylib name and also all of the things that it requires, which it requires some casting methods, the string method, or the string type, and math. And also you can say inside the code itself to include Raylib, which basically just for like C compilers and stuff would be adding the -l raylib. But you can just do that inside the file itself, so it makes it very simple. Don't have to add a bunch of arguments, which is kind of annoying. And then, yeah, basically all of this is just the types and functions and everything included from raylib. So just all this. Oh, and so for structs, of course, you have to actually define those inside of ASA. So that's just how you define them in ASA. But for the functions, you actually need to use the extern compiler directive, which says that there is a symbol with this name and, well, this prototype, really. And it lets you use those inside of your ASA programs. And I believe somewhere down here, there's also aliasing. Maybe it's not in here. I might have removed it. Nope. Yeah, I think I might have removed it from here. Yeah, it's not in here anymore. But basically, aliasing is where you can say, so basically, if you want to include an external function, it can have this name, but that might be something you don't want in your global namespace. So you can say as and give it some kind of alias like __ raylib. What is this? Set audio stream buffer size default. Okay, I probably shouldn't have used such a long name, but you can actually just shorten it to set odd stream def, sure, something like that. And basically, instead of defining this entire name as the one that you can use in ASA, it doesn't define it at all, and it defines it as this instead. It still uses this on the back end, so everything is still compatible, but it's not exposed, so it'll throw an error if you try to use that while it's actually aliased. Let's see. Let me know if the music is a little loud. I'm on a different system, or maybe even if it's a little too quiet. I'm on a different system, so all my OBS settings are completely reset. Yeah, okay. So basically Pong just includes this module, and that defines everything that you need in order to use raylib. I don't think it's complete yet. I added most of the things that you might need for raylib 5, like a lot of the 2D things, most of the 3D things, but I'm not sure if it's everything. But it's all still a work in progress, so it doesn't have to be. So, you define functions like this, the name : that's the compile time equals. These are the parameters that you can send to the function, which is the name : I think all of this is basically review because I haven't changed this syntax pretty much at all since then, but I haven't watched that stream, so I kind of forget. You can say const ref, so it's a reference and it's a constant. Const, that's just a compiler optimization flag sort of thing. It doesn't actually do anything. Oh, actually, it does do one thing. It throws an error if you try to modify this, but other than that, it doesn't really actively do anything because LLVM is still the backend, and that just handles everything for you. Oh, something that I did add since then is attributes, which is basically something that you can put before a symbol, like it starts with at, and then you can put any amount of text and a colon, and that's an attribute. It's basically something that's added into the AST of the node that follows it. So in this case, draw paddle, the function, has this as an attribute now. There are some built-in attributes like inline, which tells the compiler that this function should be put in line everywhere where it is used. And let's see, I think there's a few other ones as well, but basically you can just define your own too. It's just a string of text. And you can also have values for these attributes, like you can have a 1 there for this version 1. Version is not a built-in one, it's just something you can use, I guess, for your own internal versioning. That was just sort of like an example that I put there. But you can also have any other thing where there's like a constant compile time value. Like you can have a string or float, whatever, it doesn't really matter. So yeah. And the compiler time equals, I also kind of recently expanded so that you can put anything on the right side. It's supposed to be so that everything on the left of the compile time equals is an identifier, and then everything on the right is a value. So you can see here for the struct, for example, on the left, that's the name. On the right, that's a struct. And everything on the right should probably eventually, maybe not in some cases, but for the most part, be usable on its own. So you should be able to do something like this. So that would define this struct. And in this case, it has no name, so you can't really use it. But there are some cases where, let's see, I'm pretty sure in C you can do something like that, and then that would define this variable of the type, this struct. And so this is terrible syntax, in my opinion, but I think you should be able to do this, and using the syntax of this language, it would be something like that. The problem with this is that, well, I'll probably get to it in a few minutes, but you can't define variables with just the name and the type, at least so far. I don't think I want to do that, just for like clarity and safety purposes. But yeah, I'll get to that. So here we have like game objects. That's just instances of these structs. So I define the paddles, the ball. This is kind of like object-oriented, but I'm gonna try to avoid object-oriented thinking in this language. I already have like methods, but I don't know if I'm even going to keep those. It kind of depends. I don't really want to force like a specific programming paradigm, but also sometimes it makes a lot of software much worse if you don't have some sort of thing holding people back. Alright, so basically, I forgot if I mentioned, the compiler define is constant, so you can't change anything that is set with the compiler define operator. So, for example, this segment length, thing is just 8, and you can't change it. So this is a constant integer, and this is the exact same code as if you were to type seglength :const. I don't think I have optimization for the for like the bit width of this, but I'll just say int. The LLVM compiler probably optimizes that because it's marked as a constant, and then 8, and that's that. Okay, more realistically, it would actually be this. The int is kind of helpful, but there is type inference when necessary. But yeah, those two things are basically the same. There's not really much of a difference between them. Okay, so you guys don't really want me to explain how Pong works, but let's see. I think that's the only interesting thing. So let's see. Oh, okay. I also implemented much more of like the standard library. So let me go to that. And everything is just in the modules directory. It's not really organized how it should be yet, but eventually I'll get around to that. So right now, there's like the built-in directory, which isn't everything that's built in, which is a little bit confusing, I guess I'd say. Right now, there's, let's see, array. No. Right now, I think the only one that's actually built in is string. Oh, why is it doing that? All right, so this is the string module. It defines the string type. I'm pretty sure nothing about strings in ASA is defined within the compiler itself. So for the most part, it's all defined within this one module. There is a little bit of special handling in the compiler because the compiler by default treats string literals, which are just things in quotes. So like this being in quotes, that's a string literal. It treats that as a character pointer, which is, just that. And it can't really like differentiate between the two unless you actually like say when to do that. So I have this sort of temporary thing. It's definitely not going to stay like this. I use define, which is a confusing keyword for coming from C or C++, because it doesn't exactly mean the same thing. Well, it kind of means the same thing, kind of doesn't. The double colon compiler define is actually kind of closer. This is just visible by the compiler itself. Like it has like a map of variables and their values, and these values are just strings. Like this is not an AST evaluated thing. So like, basically inside the compiler, while it's compiling this string module, it reaches this define compiler directive, and it says in string module is true. And while this is true, which is, all of this content here, it assumes that the string, so, quotes around letters and symbols, it assumes that that literal is a character pointer, like a character, a null terminated C style string. And outside of that, in every other case, it assumes that it's actually the string from the string module, the string struct. And basically down here, so there's, the define in string module true right there. All the way down here, let me go to the end. It sets that back to false. So basically every time it goes into the module, it sets it equal to true at the top. It does all of the things on the inside, assuming that the string literal is actually a C string. And then at the bottom, it switches back over. And that's just kind of stupid way to do it. I'm probably going to fix that. But yeah, so basically inside of here, you have to... Okay, the cursor shaking, getting larger every time is really annoying. I recently switched to CachyOS because my Windows install was dying on me. Anyway, that's kind of a tangent. So this string literal right here, that is converted manually. This is how you do casting in ASA. I forget if I had already mentioned that before. But so that's casted from a C-style string to a string that's defined in the string module. So I've been working on basically the entire standard library. This is just the string module, which is kind of heavily used. I mean, strings are a basic type, so. Oh, and this is a good example of aliasing with externs. I didn't want to pollute my namespace with like C functions from the standard library. Also, this may not be... actually, no, yeah, this is cross-platform, I think. But basically, instead of having snprintf, which isn't really going to mean anything in ASA, instead of having all of that compiled, wherever I use C standard library functions, I surround it with something that kind of helps differentiate it. So I just add an underscore at the beginning, add C extern at the end, and yeah. I don't know if that's how I'm gonna keep it, because there's the chance that you can include your own extern under a regular name, and those aliases should lead back, but I haven't really tested that yet. It's gonna become a more common occurrence, especially as the standard library gets a lot larger, because people just like using those functions. Let's see. So there's another built-in question. Do you learn in university or self-made? I think I've taken one computer science class, so yeah, mostly on my own. Here's some more attributes. The public and private, where's private? Oh, do I not have private here? I might not have private. But basically there's like a public and a private attribute. I haven't actually done anything with those. They're like kind of just placeholders at the moment, because I totally have not decided what I want default visibility to be for included modules and members even. I think like the having a lot of the implementation of a type or a module in this case behind a wall that you can't edit is not... it's not very good because basically if there's anything that you want to change about an implementation, you can't really do that unless you put a huge wrapper around the entire thing. And inside of ASA, I allow, or I plan to allow, it's definitely not a feature yet, I plan to allow you to completely like redefine functions. So for example, size here in string allows you to do something like, assume you have a string called s, you can do s dot size. Obviously, like that's how it is in most languages. So this is a member function too, which I was debating. Basically, if you want this to be different, to be something like my size, you went to... I don't really know if this is a good example, because it would be wrong, but let's say you want it to return 100 always. You couldn't really do that in a lot of languages, where, you know, the string s dot size now returns 100. Like, let's say it's some kind of optimization thing you're doing where a microcontroller or something always has length 100 strings, and you don't want to hard code that in. You want to just use all the default methods and everything like that. In ASA, basically, you should be able to do something like string.size. Let's see, in this case it would be... basically just copy all that. And, yeah, you could just do that. This would have to be... let's see, so actually this type of thing would be runtime, so you'd have to do that. Yeah, okay. I was recently working on like lambdas, so I wrote that wrong. So basically you can just override this entire function. So everything following this would be this function here. Oh, and just speaking about lambdas, I guess I can say, you can have something, let's see, this is like a non-executable space, so let me just open a new file. So if you have something like the main function... oh, is this too small, by the way? I'm just looking over. Might be a little small. That's probably better. Alright, so if you have something like this, you can just define a lambda just like you would with any other function. So, for example, let's see. Let me show you like what a normal function looks like, because main is a little bit different. Some func. So that's its name, of course, and there's the type. But I know I'm kind of repeating myself here. Sorry about that. Alright, so this function, some func, you'd pass an integer x, and it would return x. Like, it's just a normal function. To have a lambda, you define that almost the exact same way. So that would be some func, except compile time equals. Like I said earlier, that is constant. So everything to the right side, it can't change. Or everything on the right side never can change. Sorry, I mean everything on the left side is constant, so you can't change its value. I did just say that I'm planning on implementing a redefinable way for functions to work. That may not, it may not be by using this the compiler define symbol, because it's kind of confusing. I may have an attribute like redefinable. The problem with this is that obviously if you don't have this attribute, then nothing is redefinable, and that kind of brings you back to the same problem you were at before. But anyway, it's a bit of a tangent. So sumfunc, the type would be, let's see, here, inferred type, int64, int return x. So you can see here that these are basically the exact same thing. Like the only difference is this symbol right here between the name and the right hand side. And you would still call this the exact same way that you would call the bottom function. So you could pass in a number, and then that just works. Let's see. Oh, actually, let's see what else I might have implemented. Let's see. I don't remember exactly what has changed, so I'm kind of just going through everything. Yes, the compiler will eventually be rewritten in ASA. It's basically there. I mean, it's possible to do now. I just wouldn't because it's lacking a lot of features. Also, there's the fact that I'd have to... The backend is LLVM. So if I want to keep using LLVM, I basically have to I have to port the header files over to ASA. And that's going to be a long process. I could do it automatically. I know that there are like scripts you can write in order to basically just parse the C++ and do it automatically, but even then I think it'll take a lot of time. Oh, and then something I didn't mention is that the attributes, you can like apply them to a scope. So all of these are public and inline. So you don't have to do you don't have to do that for all of them all the way down and just take up a ton of space. And also it makes it really easy to update, large groups of attributes because you don't have to change all of them. You just have to change whatever's at the beginning. So it makes it a little more convenient. So basically these are just casting between all of the internal types. I think most of this was there last July, but it was rather... Is music loud? It's a little loud for me, honestly. I think I compacted these a little bit since then, though. Array. Let's see. I haven't really implemented arrays. Like, they kind of work. There's not much there, though. I don't have built-in syntax for them. Like you can't do x is like an int array of 5. Like that's not a thing. The way that I don't know if I'll keep this syntax, like the this type of syntax here is used in most languages, so it would probably make sense to just add an alias, like an alias kind of syntax for it, where this means what I'm about to talk about now, which is kind of template-like syntax. I added templates, by the way. They're basically like C++. Well, actually, there are a few differences. So like this is a struct. Instead of having all of the like template, you know, etc., all the language like before it, like you do in C++, I have all of that just attached to the name of the thing itself. So in this case, it's array, and then there's the angle brackets, and then there's the template items. Like, that's basically the gist of like template syntax. Yeah. I was kind of debating whether that was a good way to do it or not. I was told it was kind of too dense because it's all kind of in the same line. But I'm also trying to make the language, I don't remember if I mentioned it last year also, I want usage to be almost the exact same as definition. So that's why, let's see. That's why, for example, functions, its return type, parameters, and, you know, value. This isn't a really good example, but basically, yeah, this is actually a terrible example. Let's see, what would be a good example? Shoot, there are like a couple systems kind of competing. Shoot. Okay, I'll just use itself as an example, because of course I'll do that. So basically, you know, it's the name followed by the template parameters, followed by the function, and, you know, its parameters. And so that's how you use templates as well. That's how you use them in most languages, but they're always defined, typically kind of weird. So I sort of thought, why not just place it with the identifier, which is how you use it. Yeah, that's probably the only example I can give, honestly. Alright, so you pretty much just define an array. You know, this is temporary, and kind of undecided, but you do it by using array and then pass the type just with its name. So if you want an array of integers, int, and then you pass the size, and you set that equal to okay, I'll get into what you set it equal to. I was kind of deciding, you know, what you should set things equal to, because I don't like this syntax. I mean, it's good most of the time, but in this case, what does this mean? Like, what are each of these integer objects inside of the array set to? Are they set to anything at all, even? Like, they could be uninitialized memory. They could be like junk values, but they could also be zeros. Some languages, or all languages, do this in very differing ways, and often they do it in very different ways within the language itself. So basically, I want to kind of define what this does, and I want to make it so that you can define what it does, like on your own. So I think I have the tab open. Yeah. So basically I just have like a bunch of ideas files, which contains a ton of different ideas for what I want the language to be. And in this one, I was kind of trying to figure out what I want null initialization to be and zero initialization. So like these were some of my ideas for zero initialization. Oh yeah, for both of them, yeah. So setting equal to void. Void was, I don't remember how long I've had void as a value. So it's not like a void in C++ or C. It's more like the null value, or null pointer even. That might be more accurate. But I don't know if I'm going to keep it like that. It's kind of confusing with most other languages, so I might just revert it to null. And I was also thinking about default, as a value, and question mark as a value. So basically, like if you want this x variable to have the value 0, you could do something like x is an integer, it equals 0. That's really clear. The problem is that it's kind of, I mean, in the case of a single integer, it's completely fine. Like, there's not really any reason why you would need to specify like undefined values. I'm pretty sure in C, and C++, if you do something like this, it is uninitialized memory. So if you were to print out the value of x, it would basically just be a bunch of random data. It'll be like a random number. And I really don't like that as the default. I think it should at least be 0 initialized by default, just for safety. So, this should be equal to 0, even if you were to not say it. But the problem with forcing initialization to 0 is the fact that it kind of ruins performance in some cases. Like if you were to have, let's see. Oh, actually, let me just open this. Nope. I can't type. All right, so if you were to have some kind of, let me zoom in, actually. That looks better. So if you were to have a for loop that basically just, goes forever, or goes for a very long time, then you have some kind of variable in there, like x int, sure. If you were to set that equal to 0 every time, like at the top, and think of this as sort of like a placeholder for just a variable that's 0 initialized. Every single time that you go through this for loop, it reinitializes this variable equal to this value. And I mean, often that's okay, like as long as you don't need it to be super fast, and as long as you're using this variable every single time, I mean, why not? But let's say you have something like, let's put an iterator here. If I is equal to 5,000, or 5,000, then print, no, let's say x is equal to I. Like, basically, I think you kind of get the point. You go through this loop 10,000 times, and every single time you're initializing x equal to 0. Every single time. X is 0, x is 0. But you only use x once. You know, and like assume that there's a bunch of other code that actually utilizes x. Like say that x is a copy of I, so that you don't want to modify I. Basically, you only use it far less than you're actually initializing it to 0. For LLVM, it would probably optimize that out. You know, find a way to make it so that it's not doing this every single time. But it's also kind of good to just specify. And also have like error checking in the compiler itself for things like, okay, so I haven't fully decided. This is like an unimplemented feature set, but let's say question mark. Let's say that's what I'm using. Basically, you know, I'm thinking of a couple of symbols that I might use. Right now, I'm kind of on default and question mark, but question mark could just be null or something else. I haven't fully decided. But question mark is basically uninitialized. So this x:int equals question mark, that is saying that x exists, and we do nothing more with that. So basically, it doesn't set any memory, it doesn't do anything. It doesn't do any of that until it's actually used. And basically, this is the exact same as what you would have in C, which is int x is not set equal to anything. And in C, that would be, you know, kind of dangerous, but okay for the most part. I don't know if I'm going to forbid not having a set operation. I'm kind of, you know, 50-50, because obviously this is cleaner a lot of the time. It's faster to write, and I mean, people are probably going to complain if you don't have it. But also this is, I mean, this is kind of better in a lot of ways as well, because, you know, you're very verbose. You're saying that this is an uninitialized variable, and it's clear to, you know, your eyes. It looks significantly different. And basically, if you're to use this with printl x, you know, that would actually give you an error. And it would say basically that x is uninitialized memory. It's an uninitialized variable. And so it doesn't have a value right now. Basically not allowing usage of that at all. Okay. And so basically the other side of this would be default. And what default would do is basically just be 0. But the reason why I chose to use the word default specifically is because, I mean, what is the 0 initialization of a string, for example. Like if you were to have s:string, oops, equals, what is that? You can't do 0 because that doesn't make sense. But you can't do null. I mean, obviously, the 0 initialization of a string is an empty... Oh, whoa. My NeoVim is lagging a little bit. I don't know why that's going on. Well, actually, I might know why that's going on. I have a few things running. Basically, 0 initialization of a string is basically just a blank string. I think that's what most of the industry has decided on. And so it's not super nice to have to write down a different 0 initialization for every single type that you have. Because you have, let's say, a float. In ASA, you can do this. You can say 0, because that will automatically be casted at compile time, and you won't really, like, there won't be any performance difference to doing 0.0 or 0.0f. But, you know, if you want to be specific, you know, 0.0. And let's do y:int. Just, you know, so it's kind of clear. So, like, you have all of these different values, and I mean, yeah, you could do this. I think a lot of languages just do this, but if you just do default, why do I keep spelling default wrong? If you just do default, then that initializes the variable with its, you know, default state. So in the case of built-in types like float and int, that will make them 0 initialized. But in the case of something like string, if I go to, do I still have it open? I don't know if I do. Let me just open a new tab. Basically, in the case of the string, which is a struct, it will just use the struct's constructor, which would be... oh, I might not have a blank constructor. Okay, so in the case of string, it actually uses the default constructor, which is just initializing the member variables to the values that they are set to. So in this case, the length is set equal to 0, and the address in this case, well, obviously I haven't implemented this initialization safety system yet. In this case, it would be equal to, let's see, address would be, yeah, I think uninitialized for address would make sense. So when you do string is default, it sets it equal to a blank string, which, you know, just has an address of default, or of uninitialized, and a length of 0. And then, you know, when you set it equal to something different later on, what it'll do is reallocate the memory. And so this address, it being uninitialized, doesn't matter. It's performant. So yeah. And it does that for all of the types. So that's why default is kind of the keyword that I'm thinking of. I haven't implemented it, but it's probably what I'll end up landing on. Question mark, on the other hand, is it's like kind of okay. I think it makes sense. Or you could do, you know, triple question mark or double question mark. I don't know. Something like that. I think it makes sense, but the main problem with it is the fact that the ternary operator exists. And the ternary operator basically only uses the question mark. Let's see, ternary operator. Is that this one? Yes, okay, so this is my ternary operator tab. I was like thinking through, okay, is it worth it to override the question mark symbol as something else that's not the ternary operator? So, you know, a lot of languages have condition, ternary operator, value of false, value of true. Let's see. And, oh, actually I didn't write as much as I thought I did. So this is kind of like what Python has. You have, you know, the value of true, and then you do if, and then the condition, else the value of false. And yeah, so as it says in the comment here, I hate this syntax. It's kind of nice because it puts the value first, but also it pushes the if later, which is terrible. So I think I'm just going to stick to this sort of syntax, which is, you know, if, then this, else, then that, which is just the normal if statement, but in line. So yeah, it's okay, I think, if I override the question mark operator. It might be a little confusing to people, but I don't think I'm going to be using it for the ternary operation. Other people, like I'm pretty sure that Jai, yeah, I'm talking about Jai again. I'm pretty sure that that has, I haven't used it, but I'm pretty sure it has like triple dash or something like that as uninitialized. So, I don't know if I would do that. I don't really like it, but I guess there's a while for me to decide. Oh, okay. I re-enabled the mouse for streaming just so it was a little easier to know what I'm talking about, so I don't have to use the keyboard for everything, but I'm not really used to using it in Vim. All right, so those are initialization. I think I can close that. There. Let's see. I also want to show you something that you might have just seen in the ternary operator file. Examples, ideas, function. Oh, I don't think I have a dedicated file for it. Okay, so I think I'll just show you here then. Okay, so something that you might have noticed is I did not use the return keyword. I used result. Basically, result allows you to give a value to an expression. That's a very broad way to explain it. I'd say this example is pretty good. So if you do print line, and yeah, I guess just an if statement. If true, then result was true. And yeah, okay, so with this print statement, what it would do is take this inner expression, it'll evaluate it, and it needs a result, like a resulting R value. So it'll basically result out this string was true if this is true. In this case, this would probably throw an error. So I probably want to do an else result false. And yeah. Also, these semicolons aren't necessary because curly braces automatically end a line's gathering in the parser. I forget exactly what it's called, but makes it a little bit easier for things like this, so you don't actually need those semicolons there unless you're actually doing multi-lines. Sorry, yeah, I wasn't paying attention to comments. Undecided. Yeah, that's the major for now. That's what I'll say. Basically, result is like return. It's almost identical to return, but you don't have to split everything out into a separate function, which, saves space. But basically, all that you need in order to use result is a scope, which is, defined by these curly braces. So let me do like result 50 plus x, I don't know. And so this scope now will just be this value. So you can do some variable int is equal to this. And let me add a semicolon there. And so basically this entire group of code will be executed like, let's say I have like a for loop here, and I loop 100 times, and let's see. I can't do this because that would give just give the first result, because result acts just like return. So this for loop would basically break out, and it wouldn't really matter. So let's make another variable called y. Make that equal to 10. And then I'll do y plus equals 5. It doesn't really matter. And then I'll do that. All right, so now we just set some variable equal to the result, which is 50 plus y. So all of this is computed, and then it's set into some variable. Basically, the reason why you'd want to do this is just, so you don't have it before it. Like, if you want to compute the value of a variable, like, why would you have all the code separate, like, before it, setting up everything that you need just to set into this variable, which is the actual thing that you wanted? So I mean, basically, the only difference is organization. There's not really much of a computation or optimization difference. Just, it's organized so that it actually belongs to the variable. I just finished my second year. I was considering like different syntax like this for ternary operator as well, but I didn't really like it. Okay, so that's result. Ooh. We got some big features to kind of get into. Oh, this was going to be a short stream. Well, we'll see. We'll just see how long it goes. Yeah. All right. So one of the things that I also want to implement is multi-return. I want to do it in a similar style to Odin, which, okay, if I remember correctly, oh, I've never used Odin, but I have looked at what their syntax looks like for this specific feature, which is multi-return. So let's just, use foo. I don't remember how you define functions again. I'm pretty sure it's like this, kind of like TypeScript. Yeah, like that. I think there's a keyword. Is it proc? I think it's, I don't know. It's something like this. And like, it's okay. I don't have this type of syntax though. My return type is not followed by an arrow. It's at the beginning, like this. And the reason why that is so that it's the call signature is just like the definition, like I said. I mean, it's pretty similar. I wouldn't say it's just like, because, names are placed here instead. But anyway, because I don't have this arrow, that's not where I put the return type. I need to actually move it to where my return type is. So if I move this over, that is almost what my functions are like. The problem with this is that this comma doesn't really work. Like you have your two types here, but this type clearly belongs to this. Or I would say, in my opinion, this type clearly belongs to this parenthesis group. So, I mean, this comma here doesn't seem to do much. You can do something like these parens, but that's kind of weird because that's two groups of parens, and it's like, I mean, I don't really like it. That's my opinion. Let's see. Another reason why you obviously want something to group them is because you can have, let's see. So this right-hand side, like I said, is possible to be standalone. You can have something like this, where it's like a lambda. And, you can call this even. You can call it like that. And then that would be 4. I don't know if that makes sense. But, basically, the right-hand side is not at all tied to this compiler define equals or this name right here. So basically, what I think I've settled on so far is something like this, where you use square brackets surrounding the two type names, or the multiple type names, which are comma separated then on the inside. I don't even have arrays like list initialization yet, how C++ or C does it, where you can do like, let's say you have an array X, setting it equal to that. I don't have that yet. I'm pretty sure I'll implement it in a very similar way, but yeah, currently that's not how that's not implemented at all. So, like, I probably would not use curly braces there, especially because it helps differentiate it, because it's square brace, then paren, then curly brace. So that's kind of nice. But I think Python, of course, has the square brace initialization. Basically, my point is I'm probably going to be using curly braces just like C or C++, and not go with the square braces for pretty much anything other than like indexing. So you can have, the array X that you had, index 5, just like most other languages. Okay, and basically I'm going to have the same sort of return handling as Odin, because pretty much it's the exact same as it would be in Odin, as it is in ASA, where you have your types, type, comma, type, and then you set it equal to the return value, or you set it equal to the call of the function, and then that handles the return value. And oh wait, sorry, this is that was the example of how it's not going to be. I misread that. Shoot, I think that's, yeah, this is what I decided on. So basically you have the comma separated identifiers with their types given. In C and C++, you can do like I, J, K is, oh no, it's like int ijk is equal to 10. And that defines each of those as an integer and sets each, yeah, and then sets the value of all of them. And basically, in ASA, you can't do that because it's really weird syntax, in my opinion. But like, you can kind of do something like that for the multi-returns. And basically, this is just handled specially by the compiler. Like, this return type of the square bracket surrounded values, which in this case, you return 0, comma, or hello, or 2, comma, blank string. Like this is not a tuple, or it's not any kind of special type, at least not at the moment. I kind of don't want it to be, because that adds a lot of complexity, because then you can start passing these around and everything. I kind of just want it to be shorthand for like foo true dot first value dot second value, and then it kind of puts those where it belongs. And yeah, I think further down there I was just talking about how like some other ways that I could do it, but I'm pretty sure that I'm just going to settle on this way. I think I need my throat to take a little break. Let's see. Okay. Let me continue. So I was using C# recently, and they have a really, really useful feature, which is, oh shoot, what do they call it? Properties? Yeah, properties. Okay. I didn't exactly remember what the name of it was. Basically, what it lets you do is give a set of code that runs every time that you get a value or you set the value of a variable. And this is really useful for like a lot of things. I primarily use C# for game development. See, I have Unity open in the background. I don't know if I'll have time, but I was also going to show you a project I was working on in Unity, which I was continuing on from last year. But anyway, my point is, it's very useful to have code that runs every single time that you access or change the value of a variable. This does have a few security things which definitely should, be thought of, but I was thinking of a good way to implement this within my language. Just in case I do, it's a bit far off probably from now, but I'll go over what I was thinking. So basically these are like non-trivial values. That's what one of my friends said the name should be for now, because I couldn't really think of a better name. Property is a terrible name. Maybe it was better for whatever they were originally used for, but what they're used for now is far more, and so that name doesn't really apply. So, let's see. I think that... Okay, here we go. So I was thinking that I could actually just define this within ASA itself. It will need a little bit of special handling within the compiler, because it'll need like a hook in order to make sure that on get and on set for these specific variables has the get and set functions called. But for the most part, I think it can be implemented just within ASA itself. And so, this is kind of what a definition would look like. You can have a value that's stored with it. Oh, and just one thing that I don't really like about C# is the fact that by default, I don't know if there's like a way to override this or anything, but typically when you use properties in C#, you have to define the actual storage variable separately. So in this case, this is a super simple property. Just get just returns itself, and set just sets it to the value. And this is the exact same as if it was just a regular variable, but assume that you have like extra code in here. You have to have, this name variable defined separately from this property. So like this is a completely different line, and these aren't really related, and they aren't passed when you pass one. So I was thinking that I might want to just have it be so you can store one inside of this struct itself. I'm not sure if it's used more with a stored value or just as a variable-like thing that has these get and set automatically called without this actual singular data value. Because obviously you can do a lot of computation within get and set, and none of that actually has to be related to one of these external values. So, this is just there temporarily. I don't know if that's how it'll stay. And then there's the get and set functions. These are just, functions that can be called, and this is just a struct. And so if you want to define a variable that's non-trivial, you would just use it, you just define it just like any other struct would be defined. So this one is an int non-trivial, and I use curly brace initialization, which isn't implemented yet, but will be, for the struct. This is the same thing as using the struct and constructor, which isn't defined for this, so you'd actually have to define it. But my point is that it constructs a new non-trivial of int using the template, and this sets the get and set functions equal to a new function. But this is like incorrect syntax. I think I might have corrected it down here. Okay, so down here what I did is I made the get and set functions be lambdas, which, yeah, I haven't implemented syntax for. Let's see, to make this a little easier. Auto is also not really a keyword, but I'm just gonna borrow it from C++. So this is basically what get and set will actually be like, so that they're actually redefinable. So these are variables, which are lambdas, and you can do... actually, you can just do this. So you'd set foo equal to non-trivial default, which is just blank. And then you manually set get and set equal to these functions. These are lambdas. So, you know, this is a ref, and it returns foo.type. This is just accessing the template value of t, which is defined here, because it's defined outside of the struct itself. So you have to use foo to like clarify it. And you know, this is just like a normal function, so this is the type. It's a reference, doesn't take any variables for get, and it returns that. And then for set, it has the return type, the input, which I don't really know what this is going to be. Any right now basically just accepts any type. Yeah, that makes sense. But it's not a type itself, so like you can't pass or you can't define a variable. Like you can't do x:any and then just change its type, because types are constant. You can't change the type of anything at runtime. So currently all that any does is it allows you to pass anything, and then the casting and everything gets handled on the inside, but that's iffy whether or not I want to keep that. And then there's the body. So basically you're just defining a variable foo, but it's not like a regular variable, because when you do foo is equal to 10, it actually calls this set function that you defined right here, passes 10, and it sets x, which belongs to, wait, hold on, x is not a thing. Hold on, let me replace that. That is val. So yeah, val. All right, so val is the value that's actually held within the non-trivial struct itself. And so you do foo is equal to 10. It uses this function instead of actually changing foo equal to something else. So it, that's just normal. And then you do print L foo, food. And what that will do is it'll call the get function, which runs this piece of code here. So that'll be val plus 5. And in this case, val is equal to 10 because we just set it right here. So this will actually print out 15. And so, that's a very basic use case of non-trivial variables, but like they have a lot of potential for what they can be used for, like especially in complex systems where certain things need to be true, or like upon setting a variable, you need to update another part of the system. So, that might be there. Whether or not people actually want to use it, I don't know. All right, and I did already kind of go over templates, which, by the way, I'm calling variant. I don't know if that'll make people mad or not, but... or if I'll keep it that way. But, of course, they're defined like that, just following the identifier. And they're used like that, following the identifier again. And you can use them for like variables, you can use them for structs, you can use them for functions. I have macro here, but I don't know if macros are even going to be a thing. Haven't fully worked through that. I think I'm just going to keep the functions as they are and not really do macros because there's not much of a point. And this is a module even that is using variants. So you have variant T, and you make it so that all of the contents of the module rely on this part of the variant. So, there's a few use cases where this could be used. I'm not sure how common it will be. It's definitely a lot more common to use it for structs and functions. And those are probably the primary ways it will be used. But like you can have something like this. Import some module and then pass in a string or not a string, the string type. And you can like have any other type. You can have anything passed to the module so that it has like those default values. It could be useful for optimization, maybe, but it'll probably be mostly used for like reducing repetition. Like if you have, just looking at these. Oh wait, hold on. I don't know why those say ST. Oh, okay. It's borrowing that struct. Yeah, okay. Basically, instead of having to pass this string to every single part of the module every time you use it, it's just already there. The main problem with this is that, well, I mean, what happens when you do that? I don't really know. I don't know what should happen. I mean, of course you can do something like, oops. Like you can write out the full name with the module included, and that would work when you import it. But, you know, there's nothing exactly stopping you from doing this. The difference between import and use, by the way, is that use imports all the content. Import imports the entire thing, so you still have to use the full name. So if you were to do use, then you'd have to do init. So yeah, that doesn't have the variants, so you don't have to actually specify because it borrows everything from the module that it's imported from. But it kind of lacks clarity when you do something like that, because now what does init mean? There's an init in this one and this one, and they're the same type of module. The only difference is that they have different variants. So, I mean, I could allow it, or, you know, maybe just add a warning. Or no, not a warning, an error. This would be an error so that you... you have to put the full name, basically, because it's a name collision. Yes, this is probably the way I'll do it. And... let's see, what is left? Oh, compiler directives. Ugh. Okay. Let me get another sip of water here. Let me also maybe change the music. I think I'm getting a little bit sick of it. Like a headache. This is also Skyrim music. Maybe this one? Silent Hill. Okay, hold on. I mean, that's still Skyrim music. YouTube is not recommending me anything different. Here, lo-fi, I guess. Not the rain. Animal Crossing, okay. Tell me if it's too loud again. Oh, this one might be. It's at like -24. Okay. So, now I want to talk about something that is the compiler directives. For currently, all compiler directives are just defined within the compiler itself. Like, you can't define your own. For example, you have import, and then you just, put the name of something, some module that you want to import. There's extern. I cannot type. And then, there's the prototype of the function that you want externally. And you can't really add any of your own. You might wonder why you would want to add some of your own, and basically the answer to that is metaprogramming. All compiler directives are executed the second that they are, or when they are met inside of the compilation, inside of the compiler during the compilation process. So basically, let's see, where's one with import? Here, okay. So use, for example, the second that this part of the AST is reached in the compiler, it will import this module, and it'll basically place it at this kind of location. It doesn't do the C++ or C way of doing it, where it pastes it all as text. It actually compiles the AST and puts the AST there. So, like, it won't cause any text problems. There's no preprocessor or anything kind of dumb like that. So another good example is type of. So, you put a variable there, or you put a type there, and that evaluates the type of this thing when this part of the AST is reached, and it converts it into a string. And there are like many other just like that. And you'd probably want to make some of your own, but also I probably want to make it so that I can define them within ASA itself, because defining them within the compiler, while it does kind of allow like good error handling and everything like that, it also takes up a lot of space, and like it's just not really a good way to define a bunch of things that are very similar. So I was open the wrong file. So I was thinking about how you could define them within ASA. The first way that I thought of was, just doing the directive name and then defining it exactly like a function. It's kind of a weird way to do it, though, especially because just like I showed, come on, load. Oh, it was loaded. Just like here, you can pass arguments to compiler directives, just like a function. So it just kind of makes sense that you define it like a function. But then that means that, AST, like you need to pass, you're passing an AST. You're not passing an integer. You're not passing a string. You're passing an abstract syntax tree, an object, which could be anything. And so if you wanted to use the same syntax as functions, you'd also need to have types to describe all of the types that it could be, which is just AST, so it's kind of redundant. And also the double colon, well, the double colon is the compiler define operator. So that means that everything on the right side would need to be allowed to be able to set to anything. So you should be able to have it be like that. But then that would mean that, the AST type is built into the language, and it's not just reserved for compiler directives, and that's wrong. So basically everything, all of that is wrong. I don't want to have it defined like a normal function. I could have it defined sort of like this, but the problem with that is that, this is the exact same way that you use functions. So it's, it might make parsing more complicated and make the way that you use them more limited. Because, like, what's the difference between, this and, some separated braces? It's not very clear, I guess I'd say. And okay, so basically there's a lot of writing here. I was basically just spitting everything out on the page. But I think what I settled on was one of two things. So the first one I was thinking was, actually, hold on. Is it there? Sorry, I'm just rereading. Yes, I do. Although it's summer vacation now. Okay, so basically, I think pretty much what I decided on was using another compiler directive called make directive, and then just using a string for its name, so that you don't have something like this. Because the problem with using a hash in the directive name that you want to define is the fact that this is a completely valid way to use a compiler directive. So it just makes parsing a lot more complicated. So I want to simplify it to be something like this, where it's actually a string until it's actually created. So this also kind of simplifies it because this is, exactly how you use a compiler directive. So this is actually parentheses right here. And then these are each just an argument passed to it. So, this is a string, comma, this is paren surrounded argument name sort of things. I don't think this is how I kept it, yeah. And then this is a scope. And so all of those are just arguments passed to this compiler directive. And I think that the way I did it was... oh no, I guess that is the way I kept it. Yeah, so I have make directive, pass the actual directive name as a string, and then I have parentheses surrounding the argument names. And these don't have a type because all of their types is just an AST. There's nothing special until it actually is turned into data. And so you're actually directly working on the AST itself. And basically one of the examples that I provided that, someone might want is... oh, actually, I didn't provide a good example. I provided kind of an example of how I would implement part of the language. I guess I can explain that. So there are a few compiler directives that I will need to make in order to make this possible. So obviously there's the first one, which is make directive. It lets you make a compiler directive. So obviously we need that. And some of these are all missing parts because I'm kind of taking parts of some and kind of mashing them together, but it should sort of work to explain. So this is how you might define an else if directive. Hold on, this music is a little loud again. Okay. So I'll also need to have the if directive because otherwise there's no way to check if a condition and then have some kind of code. As well as the return directive, which lets you give a value out. And I think, yeah, and also need some compiler directives for a global stack. So basically, in this example, let's see, how does that work? Okay, so yeah, basically it utilizes variable. Okay, so yeah, I also need another compiler directive called, I mean, I wouldn't call it this. I used var for storing a variable. I probably wouldn't keep it though. So basically, you put a value into this variable. And also stacks in order to keep track of actually where you are in execution. So if you have something like, yeah, like you can have if, that's the first argument, then do this. And then else, it's just the scope body. But basically, all of these are executed at compile time, and so you can't use the regular if statement. Like you can't do if A is equal to B, then return C. And the reason why this is because this has an AST, and the AST that it is does not execute at compile time. This is a runtime only type of piece of code. So you need to use compiler directives for pretty much everything in the definition of a compiler directive, because it's all metaprogramming all the way down. And so compiler directives don't have any way to connect to each other. It's basically just a function call. And if an if statement is a function call, then that means that anything after it's called doesn't know that it's been called. So inside of if, it needs to push to the stack, or a stack, that it is an if statement that has just been called, and it's let's see, so this is stack last, and this is a stack called directives. Basically, it's just the last used compiler directive, and yeah, okay, so it's modified only after the directive fully runs. And the reason why that is because if it was updated, when it runs, or, right before it runs, then it would just get itself. So basically, after it runs, it adds itself to the last run stack. And then this else statement, or anything else that's following it, like this else if that's defined down here, that can access the last directive from the stack, and it can know, well, did this if statement evaluate to true? If this if statement evaluated to true, which it can get, from the stack, then it executes itself. Otherwise, it just does nothing. So basically this is how I'm currently thinking of doing metaprogramming in ASA. The problem is that it's kind of complicated. I don't typically do a whole lot of metaprogramming inside of languages, but that's what Jai is known for. That's I'm pretty sure Odin is decent at that, or Zig. I don't know. I speak, even though I haven't used those languages. I think I used Odin a tiny bit, but not significantly. I'm mostly a C++ person. And so this is how it will be for now. But the good thing with compiler directives is the fact that like they're really out of the way. It's not a huge syntax thing in order to change it. It's basically almost the exact same as regular code, except it's like only very slightly different for many things. Not everything, but many things. And okay, so I think that was what I wanted to talk about for these ideas. And what I also want to show you is a few more examples. Running examples. No more just staring at code, which we've been doing for about 2 hours. Okay, so we've already looked at Pong. Let's look at the Raycaster. Yeah, let's just do that again. Oh. The microphone's right in my way, so I'm kind of looking around it. All right, so this is the Raycaster. Oh, it's on the other window again. Basically, I was just kind of trying to write something that looked sort of like Wolfenstein. I say sort of like Wolfenstein, but I definitely stole these textures from Wolfenstein. There's no gameplay at the moment. Like you can walk around, you can look around. I made some like sprites that billboard to the camera. There's a mini map, and there's doors that open and close. And like this, oh, close? Does it close? Why is it not closing? I'm not sure why this door's not closing now. It's a bad demo. Okay, it closes from this side for some reason. Huh. Well, that's a bug. But basically, it's just Wolfenstein. Like, it's not really technically impressive. But let's look at some of the code, I guess. I'll go through it pretty quickly. So here you can see, I used void for the like null value for pointers. That's how it was, and I think that's still implemented. But yeah, I'll probably change this to be null or default. These are all constants. This is the level, which is just stored as a giant string. I think I don't use all that much new things that I didn't use in Pong. There's like vector 3s, things like that. Hold on, this music is a little annoying. Sorry, Nintendo. Minecraft. That might be fine. Too much rain. All right, that's probably fine. Okay, so basically, main function that just initializes raylib and everything, draws everything, minimap, sprite, doors, move, and update function. And it's probably very poorly written. I haven't really made a full raycaster before. Like, this is kind of one of the first times I've done it since I think I followed the One Lone Coder tutorial a while ago, but shoot, when was that? That was like 7 years ago, probably. Yeah. Yeah. So that's pretty much everything. And I also implemented, or implemented is probably a strong word. I very easily ported one of the examples from raylib themselves, which is a like 3D model which rotates. So I'll show that. I think it's this one. Yeah, so basically I just like took it straight out of the raylib project directory for their examples. And I ported it because, I mean, it was like very simple code. The only thing that I didn't port is like the drag and drop, because I think it was having an issue. I haven't tested it for a while, but yeah, basically I'm just trying to like draw the 3D model. That's all that I wanted for this example. So I'm just gonna okay. And that's on the other monitor again, but here we go. So yeah, it's just like a castle that's spinning. I don't think it's even using any shaders. It's just... Oh, I guess I can't do that. Like it's just the built-in shaders, I think. But yeah, it was super easy to just port it, so figured why not. And I think that's like it for those ones. And oh, that's a little messed up. Well, here you can see my to-do list. It's pretty full. I'm not really going to do any of this today. I'm mostly just showing off because some of these things require a lot of thinking and I can't really do that with an audience. So I think what I'm going to show you now is the error system that I've been kind of working on for the past like few weeks. It's like really basic. It's mostly just on the UI side, but I don't know, some of you may find it cool. So if I do build, and I'll just pass a flag, which just, it like tests a ton of errors. So it'll just show you what they look like. All right, so let me just like start at the top. All right, so basically I kind of wanted to use somewhat similar syntax to what Rust uses, but make it better because, I mean, there are a lot of pointless things that they do, or things that I find pointless, they might not find as pointless. But basically, you know, there's the error number, and the error information text. And then below that I have like a context thing, which is basically just some text that says what it was doing in the code gen when it threw this error. And then there's the file name that the error originated from. And then there's like the lines of code surrounding the error. And then there's the line that the error occurs on itself. And it has an underline, and it has a line connecting to an error like short message. And then it says errors were encountered during compilation. Like, I mean, it's just an error message, so I guess it's not like that interesting, but I guess there are some more interesting cases, which I'll show you. So like this one's an undefined function, and it gives suggestions down here because these two functions were already defined. So yeah, like this one doesn't have a value passed to it. So these ones which have values passed to them, it suggests those because you could have met them. And all right, this one's kind of similar. This one is for a function where you pass a value to it, but it's not the same as the function definition itself. So here you pass an integer, but this foo function was expecting a float. And now in ASA, you can do this. Like, this would not normally throw an error. But in this case, for this foo function, it has, it says that this type has to be exact. It has the exact keyword. It's just like const or ref, but if you put exact next to the type, it means that it won't do any automatic casting or conversion. So that way you can make sure that like extra casting is not happening in the background that you're not aware of. And it can also, like you can optimize, so that's useful for that. And also any casting that might lose precision, which is like really important. So yeah, so that's why this error is occurring, but it would also occur if you were like passing an integer to a string valued function or something like that. This one's like an unsupported cast. So X is a string and you're trying to set it equal to, you know, a double. Use of undefined variable, undefined variable. Okay, so this one's a little more interesting. Function redefinition. So here you redefined a function and it marks it with red, and the function that was previously defined is marked with blue, and because it's in the same file, it is actually shown in context connected. And if it's in a different file, it actually like separates them out. And you can also have like these error tests are basically just making sure that none of the error messages get messed up or get broken at all. So in this case, the error occurs on the same line as the redefinition. So it's the exact same error as above, except everything is just put on the same line. And so this just shows that it won't break if you actually have something like this. And here we have like invalid compiler directives. I have like basically just a bunch of checks for the compiler directives, like define needs a name and it needs a value. So obviously it throws an error. And library, that one, it needs a string because that's the path or the name of the library. And this was, you know, me sort of starting on the required initialization value. So, you know, equals void is kind of, you know, what I did temporarily. but this would be changed to equals default or equals question mark or equals a null or whatever I decide on for the question mark, non-initialized, basically. So it just throws an error here saying that it's not initialized to anything. And obviously there's inferred types in ASA, so you can do like x is equal to 5, and it'll know, okay, I'm going to define a variable named x, and I'm going to set it equal to 5. But if you have this kind of null initialization, like if it's default or if it's void in this case, then you can't have type inference, because this value doesn't actually carry a type. 5 carries a type, but void is used for all types, or default or question mark. Those are all used for all types, and that's the point of them. So in that specific case, it will actually throw an error because it can't really infer any type from this value. Technically, it could maybe do it later on, but that's ridiculous. I probably wouldn't do that. And yeah, that's the same error. And I also have an error or some errors for attributes. I don't remember if I mentioned the external and internal attributes. Basically, in LLVM, you can mark different symbols or functions, I'm pretty sure mostly, as internal or external. Basically saying if it's external, then it needs to be accessible, like it's a library, basically. So it can't be like mangled, it can't have any weird operations applied to it. And if it's internal, then it like only things inside of the binary itself are supposed to access it. So you shouldn't really care about what its name stays as. And so some of the attributes are actually completely incompatible with each other. Like, I think I mentioned the public and the private attributes. You can have, public and private on the same thing, but it'll throw an error because that doesn't really make sense. I considered having it be so that the latest one, that's like lowest down, is the one that's actually used, and then just being silent. But I can think of a lot of cases where you have many attributes which, kind of blend together. And so, you might miss something like public being up here and then private being down here, and then that messes up your entire code base and it's silent. So you definitely wouldn't want that. So instead, I have certain attributes marked as completely incompatible with each other. And it's obviously only the built-in ones. I might allow a system for marking custom attributes as incompatible with other ones, but I mean, that'll probably be a compiler directive thing. And so basically it shows an arrow connecting to the first and the second incompatible attributes, and it shows what they belong to and just the context around that. And I also showed what happens if you have them on the same line. I haven't really added enough tests to have it like have many attributes on the same line and they're all like combined, because this might mess up then. I'm not entirely sure. It's not like super robust. I'll probably make a way to have it fall back to something where it like places the message down here with this one and doesn't have any connecting lines or arrows. But haven't done that yet. And I also mark duplicate attributes as incompatible with like, if you have two public attributes. I don't know if I'll keep this as an error. Probably not, actually. I'll probably just make this a warning, because having two attributes that are the same thing might be okay. The only difference is with attributes that have arguments. Like you could have like that version attribute that has like the 1 or the 2 passed as an argument. Basically, it's saying like the version is a variable and it's equal to this. And so 2 would override the first one. And so the warning wouldn't really, or no, the second one would override the first one, like in order. So, you know, you could have 2 down here and 1 up here, and it would override that one because they're evaluated in order. And just having a warning for that could cause a lot of issues, especially with metaprogramming. So I might keep it as an error just because that would be safer. But that's something I have to decide. Oh, and this is an example with the line, you know, going around a comment or going around a long line. And that's another one. All right, and then this is another one where the line is, it's long, but it's like very long. And I make it so that it actually truncates so that it fits within, you know, the width of the screen. But I make it so that the line for the message itself doesn't go all the way around that, because I mean, imagine if this used here message was at the end of this comment, it would be all the way over here, and that would be that wouldn't be very nice. So I basically just have it, if the line gets truncated at all, then the message just goes back all the way on the left, and it goes kind of through or under. I call this underpass in the code. So like these symbols kind of indicate that it goes underneath the message or the long line. Let's see. Undefined member. So, you know, if you try and access a member of a struct, that'll give an error. And I also have it so it says what the candidates could be. So I have an A variable, a variable named A, and a variable named B under this struct. So pretty simple. Oh, and I have 2 kind of special attributes called deprecated and removed, which are basically, let's see. This is what the test cases look like too, by the way. So basically, with deprecated and removed, you can have this attribute applied to like a function or a variable or a module, basically anything that you can already apply attributes to. And then whenever you use it for removed, what it'll do is it'll give an error. It'll say, this function or, you know, whatever has been removed. So basically it allows you to have built-in API like deprecation and removal for, you know, whatever program that you make or libraries or whatever. And so you can also like give a message. So in this case, like you try and call the foo function, but this has been removed. But the removed attribute has the string use bar instead. So it actually can like tell you how to use the library just by using attributes. So in this case, this is just a normal removed attribute. So it says it's been removed. It doesn't give any extra context. But in this one, this is the one we were just looking at with the extra message right here. This one includes the message at the end. So it says foo has been removed, use bar instead. So yeah. And let's see. Same thing. Attributes. Okay, there we go. So these are now for deprecated, which is down here. Deprecated is the exact same as removed, except for the fact that it doesn't have a hard error, it just gives a warning. So you can say that foo has been deprecated, but it still works, but like you should move over to it, or over to something else. So in this case, it just says it's deprecated, and this is a warning. And you can also give a message as well, just like you could with removed. And here I was just testing out multiple warnings in one compilation of a program. So here you can see, it's been deprecated, and this one has also been deprecated. So like, yeah, basically you can have multiple warnings. With errors, as you can see here, basically these lines with the text, that's just separating each of the tests. That's not actually what the output would look like. Basically, this is just the entire output right here if you were to compile this program. And currently warnings, since they're non-fatal, and not really important for ending compilation, you can have multiple warnings in one compilation of a program. But currently, errors immediately end compilation the instant that an error is met. They're all fatal, and this is not how it's going to stay. I've started working on a way to poison AST nodes. Basically, you just mark it as poisoned, and then anywhere it's used, it won't compile that. It won't compile using that poisoned AST, and so it should allow you to actually have all of the errors listed and ensure that none of them are related to one another. So you don't have one error that causes 10 errors and then none of them are actually related because only the first one actually mattered. Okay, well, let's see, what do I have to do now? I'm not sure if I had anything really planned after this. I think that's everything that I had to mention, actually. Yeah. I don't think... Yeah, I'm not gonna really do any development on stream, at least for now. Oh, I can talk about some of the upcoming features. So one of the things, like in Pong, let's see, where's that? Here? No. Right here. I want to add a compiler directive for recommending options. Basically, you can pass options, obviously, to the compiler. So like, there's the -o option, which is just the optimization. It's just like in most C or C++ compilers. So you can do 0, 1, 2, 3, Z, S, fast, things like that. And so it's like, oh, I didn't pass a path, but so you can basically say you want this as an option to be passed to the compiler. Like, it won't actually be appended, it'll just be processed like options are processed. And it'll basically, it won't do it by itself. It will ask the person who is compiling, like it'll say in the terminal, it recommends so-and-so option, and you could say yes or no, whether or not you want to actually use those options. And so like that's probably a good trade-off between, like it's a bit more secure if you ask the person. It takes a little more time though, but I think it'll be more beneficial because obviously being able to pass options just by being in the code itself, that'll make compilation and build processes way, way easier for like a lot of cases, I'd say. Yeah, I'm going to be adding all of those compiler directives, like, if different stack operations, just for keeping track of things in a metaprogramming sense. Errors for, this style of error, warnings, and a context pointer so that you can, well, I probably don't have to explain that. That's kind of a little too in-depth. Yeah, initialization, default and uninitialized values. Oh, I want to add defer. I don't know if any of you know what defer is used for. It basically allows you to push an expression to the end of a scope. So you can do something like, oops. So let's say you have like, some like big, huge objects. Like it has a ton of data, it has a bunch of different like sub objects that need to be kind of handled. And we'll just yeah, make it something like that. Is equal to something like some initializer. And basically, oh, actually, let's make this not main. Let's make it just some function. And let's say you use this, all throughout the function. Just wow, my tab complete is really slow for some reason. And let's say you have like a ton of returns, like if true, I don't know. Oops, I accidentally pasted. And then you have like another return down here, just returns nothing. Like a loop. Okay, so basically, this some big object, it's causing a memory leak. So you need to actually remember to destroy it at some point. So let's just call some big object dot destroy. That's like a function defined inside of the struct itself. There's no built-in destructor yet, so that's just handling it all manually. Oh, hi, welcome to the stream. All right, so this destructor, we basically need to have, before all of the returns, So, you can obviously just have it down here. That's easy. It doesn't take up any space. But the problem is that we have many more returns. And, these could be returning actually different values. So, you can't just have a go-to and have a, let's see. Something like that. Like you can't just put go-tos here and then return, because you could have many different return values and branches. So what defer allows you to do is basically just put this up here. So they're actually right next to each other, the initializer and the destructor. And then you can do that. And what this does is, instead of calling this destructor right here, it basically takes this code and it puts it before all of the returns. It doesn't literally do that, because obviously that would take up a ton of space inside of your code. But what it does is it effectively makes something like it basically converts it into something like that, and then puts like a go-to before before all these returns, and then it actually does the return. So it makes it so that not only is the destructor right next to this initializer, it also cleans up all of your code, so it's just really nice. I hadn't really heard of the idea until I watched a podcast with the creator of Odin, who talked about it and how nice it was. So I'm just going to implement that as a feature. It'll be really, really nice. I even actually forget exactly where it is. It's not here. I actually have a somewhat similar version in C++, which isn't as good, unfortunately, because it doesn't really work the same. C++ doesn't support it very well. No, I don't think I have it open. Let's see, so here's the code gen. Yeah, okay. So basically in C++, this is actually a macro, and it has kind of function-like syntax. And I'm pretty sure it only works with function, so you can pass a function to it. I don't know if this is defined in here. No, it's not. Maybe the header file. Maybe the parser? I don't actually remember exactly where I defined it, but it's basically just a macro that puts it before the end of the scope, so it's really useful. My evening's been great. How's your evening been? Oh, and I was also considering making variants use a $sign before their name, kind of like PHP syntax, but I was told this was stupid. I was told it would be very painful for your fingers to constantly press the $sign. So maybe not. I kind of wanted to differentiate variant variables from regular ones, but maybe people don't find that a very big deal. Not super sure. Oh, and I added enums. I don't know if I even mentioned that. I don't know if I used them anywhere, actually. I may not have. I don't think I've used them in any of the demos. Wow, thank you. Oh, all of the base compiler files are actually like handwritten. I didn't borrow them from another compiler. Let's see, where's CodeGen? I think I closed that actually. Yeah, it's kind of a pain because just this file is 7,000 lines of code, and it is kind of not very fun to maintain. Basically, this is just converting the AST into LLVM. That's all it does. So, yeah. Oh, yeah, I can... Yeah, let me share that, actually. Let's see, where is it? I think I can do this. Like that? No. Where is it? Maybe it's not defined like that? Oh, it is searching. It's using grep right now. I don't know what it's doing, actually. Oh, there we go. It found it. That took a while. Oh, it's in message handler. Why is it in there? Okay, so this is basically it. I think... Yeah, okay, just that. I don't know if I can paste this in chat. Yeah, I can't even paste that in chat. It's a little over the character limit. Oh, I'll just give you the pastebin link. There you go. Okay. Another feature I was thinking of implementing was like automatic options. I think Python has something similar where you can basically just define a function and have that be an option, like a command line option. So like if you want to have your program, like this is for code compiled in ASA, not the ASA compiler itself. So let's say you have like say you're running your program and you want to pass an option and call it something like sum opt 5, right? Basically, I don't know if I will do this because it's kind of a weird thing to do and only used in some circumstances, but let's see. I guess I can just do that. Um, yeah, so basically what I was thinking is having a function called SumOpt, right? And then you just define that like a normal function. And let's see, int. And maybe having like an attribute or a compiler directive. And I don't know how it would be used. I haven't even like thought that far ahead. Like command or probably option would be better. I don't know why I used the word command. Command option might be too long as well. Basically, you have to have like some way to register it, because obviously the main function is... I don't think I've even tested this, but basically, obviously the main function has the... count. I don't think I've tested options in ASA. But, you know, we'll just wing it, I guess. And I don't know what args will be. I want it to be higher level than what C is, but I'll write it the same, I guess. You know, a pointer to character pointers. And you'd have to have maybe some kind of built-in function. Like currently, there's the getOpt. Where's main? Main. There we go. How I get options right now for the compiler is I use... I define all the options like this, and I use getOptLong, and this sucks. Don't do this. I mean, it's better than nothing, but I probably will replace this. And then it's like a giant switch case for each of the arguments, because it just loops through each of the arguments. And this should probably be better. So, either an attribute that it is an option, or some kind of compiler directive, and then some kind of function to process it. The problem is that it's kind of weird. Like, you might have to do a compiler directive instead of a function, because the function won't be... It would need some kind of meta programming, because it needs to choose which function to call at at runtime. So it's not... Yeah, it'll need to like expand into a giant switch case, just like it was in the example I showed you. So yeah, I don't know if I'll do that or not. Just some bug fixing. I might add a embed binary compiler directive. That's definitely a thing that could be useful. Basically, you just say embed binary, you give a, you pass a file, and then it basically stores everything as a hexadecimal array. That's like just genuinely useful. I mean, in the, well, basically, if you wanted to like store assets within the binary, like icons, colors, textures, sounds, I don't know, like anything like that you might want to just be stored in the binary for simplicity. It would just make it like really easily done, because you can just store the file itself as binary inside of the executable. Multi-return reference. Oh, calling convention. I don't know if any of you are interested in ABIs, but like, yeah, definitely like more confusing than it should be. Right now I have most things using like the C calling convention by default, just because it makes it easier for using libraries because everything is just the same. But it's also very old, and I also think that there's like a lot of things that can be optimized about it, but I don't know enough at all like about any of the different types of calling conventions. So right now it's basically just as minimal as possible in order to make the compiler work with standard libraries. And the array type, that's also something else that I have to do. Like actually make arrays a part of the language, because currently they're very much not. All right, well, I think that's pretty much everything, I guess. I'll try and stream again sometime. Problem is with this compiler is that it requires a lot of thinking in order to actually get anything done, so I probably wouldn't even be talking for most of the stream if I actually have to implement a difficult feature. Oh, and I forgot to mention, oh, something fell. Thank you everyone, for all of the new people here. It's quite a bit. It's like, I think almost 10 times what it was last year. Which makes sense when you actually post something on the channel rather than just being live streams. So, thank you everyone that's new here. And yeah, thanks for being here for this stream, and I'll see you all